Let's talk logarithms and have some fun. So what's a logarithm? This is a new topic. And what a logarithm is going to be the inverse of exponentials. So when you learn about addition, you then shortly follow with subtraction. You learn multiplication and then division because those are inverses of each other. So since we talked about exponentials, now we will talk about logarithms. So let b and x be positive numbers where b cannot equal 0. Then what we have is that the log of x with a base b is denoted log base b of x. And it's defined as the exponent y that makes the equation b to the y equals x true. Well, what does that really mean, right? So what a logarithm is that if we have some exponential in the form of b to the y equals x, then a logarithm can be written as log base b of x equals y. And what that's saying is it's saying, what exponent must I raise b to get x? A logarithm will find that. So let's do some examples for it to really make sense. However, this chart, you want to make sure you memorize the conversion, okay? So for example 1, it says convert the following into exponential form. So you can see this is written in log form. Again, the way I read this is log base 10 of 100 equals 2. So when I convert this to exponential, what it's saying is the logarithm here is telling me what exponent the base would be raised to make 100. So converting, the base is 10. So in my exponential, my base will also be 10. But what the log equals is the exponent now. And it equals 100. And let's see, does that make sense? Is 10 squared 100? It is. So I converted to exponential form. So again, our base b becomes the base of the exponent. What I'm taking the log of in our original, it's x, is what the exponential equals. So I took the log of 100, and that equals for the exponent. And then what the log equals becomes the exponent. Let's do another one. Log base 3 of 4 equals y. So my base will be 3. The exponent is what the log equaled, and that equals 4. Okay, now, I also want to share that it is totally okay to also write these where you keep, for instance, 100 on the left-hand side and then do 10 squared. Remember, those are equivalent statements. Same thing here. I could say 4 equals 3 to the y. So it doesn't matter which way you write that when it comes to equations. However, we will look at inequalities, and then it's important that whatever variable the side was on, it stays on that side. Okay, you try converting 3 and 4. Now let's look at going the other way around. So I'm in exponential form, and we want to write it in log form. So I write the word log. Our base in the exponential was 7, so that's the base of my log. So it's a little subscript, a little 7. The log will be, what we're taking the log of is what the exponential equaled, so 1/49th. Notice, log and 1/49th are written on a level playing field. The 7 is the subscript. And then the log always equals what the exponent was, so -2. Let's do another one. The next one, log base 4 of 16 equals my exponent. Now, here's where this comes in handy. On number 2, we could do this out, right? We know 4 squared gives me 16, so I can find x very easily. But let's pretend it was 4 to the x equals 19. We don't know that off the top of our head. So by converting it to logarithmic form, it would be log base 4 of 19. I could then use a calculator and solve that quite easily. So that's going to be the purpose for this, okay? We're going to focus on the converting and solving, but you will see where the log is really helpful for. So you try 3 and 4 converting. All right, now let's try simplifying these, okay? Or solving if there's a variable. So for number 1, I'd look at that and say, geez, I don't know, log base 2 of 8, what does that mean? Well, we have our conversion. Remember, What a logarithm really is saying is it's saying, what should I'm going to write this with words. What should I raise the base, which is 2? So what should I raise 2 to get 8? That's what it's saying. So 2 to what power gives me 8? And we know that, right? That one we can do in our head, or we can convert that to say 2 to what power gives me 2 to the third, right? 8 is 2 to the third, right, with the same bases. So now my exponents are the same. So this answer is 3. Number 2 is saying, what should I raise 8 to? So 8 to what power? In this case, we have an x, right? We can actually literally convert that. So 8 to the x power equals 164. And now from our last section, we know how to do this, right? We rewrite these with the same bases, 8 to the negative 2. And now my bases are the same, so x equals negative 2. Okay? So you try doing 3 and 4. Solve for either, in this case, we're solving for b for number 3, and in 4, you're just simplifying. Okay, now we have some key important special log values that you want to have memorized, okay? So the log base a of 1 equals what? And what this is saying is no matter what my base is here, if I have a 1, what will my answer be? Well, we can think about the conversion. What this is saying a to what power gives me a 1. Well, no matter what a is, whether it's a 1, a 7, a 400, whatever I raise that to, I have to get a 1, and that would be the exponent 0. So when you say you're taking the log of 1, it'll be 0. For number 2, this one, if I converted it, would be saying a to what power gives me a, right? That's what a log is saying, is take my base, what power do I raise that base to get what I'm taking the log of? So in this case, this is really a 1, so that question mark would also equal 1. So when the base and what you're taking the log of are the same, it just makes a 1. Okay? For example, if I said log base 5 of 5, that would simply just equal 1. Number 3. So number 3 is saying, okay, what should I raise the base of a to get a to the x? Well, the bases are the same, so that would mean the exponents would both have to be x. So an example for this guy would be if I had log base 7 of 7 to the 5th. In this case, the 7's cancel, and I'm left with whatever that power was. So this would just equal 5. And last but not least, we have an exponential. So when I have an exponential raised to a log, we convert that to log form. That would be saying the log base a has to equal log base a of x. So what would that be? Simply x. So this example, I could have 2 to the log base 2 of 3. And those 2's would cancel each other out, so we're just left with the normal number 3. Okay, so 4 properties to memorize. Okay, and the last part of this is our graphs, okay? So let's just reiterate again what a logarithm is. A logarithm is saying what power should I raise something to get my answer, okay? And we go back and forth between exponentials. When I'm graphing a logarithm, understanding how to graph an exponential is going to be really helpful for you, okay? So exponentials and logarithms are inverses of each other. Thus, their graph reflects over the line y equals x. Again, we have our parent function of log base b of x. So that base value, that b value, can change, okay? So we don't have one set parent function. However, when we are doing these, okay, we want to think about the most basic function and then apply our transformations afterwards. So with that being said, our vertical asymptote, remember in an exponential, we had a horizontal asymptote. So since this is an inverse, we're going to have a vertical asymptote, and that'll be in the form of x equals some constant. Right? Remember, an asymptote is a line that the graph approaches. So in this case, it's a vertical line that the graph approaches. And before, for our exponentials, when we found our horizontal asymptote, we looked at the vertical shift. So to find our vertical asymptote, we're going to look at the horizontal shift. Okay. Our domain is found because this is our domain is our x values, and we had our vertical asymptote that deals with x. That means our domain is found by the vertical asymptote. Okay, the parent one is from 0 to infinity. So now if I shift to the left, 2 now will be from -2 to infinity. If there's a reflection over a certain axis, we may be from -infinity. Our range is going to be all real numbers. Remember, for an exponential, our domain was all real numbers. So since this is an inverse, we'll have all real numbers for our range. All right, now how are we going to graph this? The first thing you're going to do is graph the parent function, the most basic one without the transformations. Oops. And by doing that, I apologize, instead of just saying graph, we're going to identify the parent function. Okay. You're going to convert that parent function to exponential form. Now from there, you're going to plug in values for y to determine x. Now that's the difference, right? And when our exponentials, we tested, our x values, -1, 0, 1, 2. This time we're going to plug in values for y. And that's again because we're dealing with inverses. And last but not least, plot your answer and any transformations. Okay, so let's look at 2 of these examples, and then I'm going to have you try 2. So the first one is a parent function. It's y equals log base 3 of x. So it's the parent function of log base 3 of x. So what I'm going to do is, since it's a parent function already, we're just going to convert this to exponential form. Remember, for exponential form, we have our base is 3, so it's 3 to the y power will equal x. Okay, and again, that conversion comes from the top of our notes. Our base is 3, the exponent is what the log equaled, and what I took the log of is what the exponential equals. Now that I did that, I'm going to make a table of values. But I'm going to plug in for y. And since there's no transformations here, I'm just going to plug in my sort of go-to ones, -1, 0, 1, and 2. When I plug in -1 for y, okay, that's going to give me a 3 to the -1, which is 1/3. When I plug in 0, 3 to the 0 is 1. When I plug in 1, 3 to the first is 3. And when I plug in 2, I get 9. So I'm going to plot those points. So I have 1/3 -1. So it's somewhere like this. I have 1, 0, 3, 1, and 9/2. Now remember, this is a parent graph. So as I said above, for our parent graph here, my domain is going to be from 0 to infinity. So what that means is that my vertical asymptote will be at 0. My domain will be from 0 to infinity. And as I said before, my range will be all real numbers. So I'm going to sketch that asymptote first in a different color. Vertical on the y-axis at 0. There were no shifts. And now I connect those points. Remember, we approach that asymptote, but we never pass through. And I apologize, it's a little tricky to connect the dots perfectly. So there is my logarithmic equation. And think about that, right? Remember, you don't need to draw this, but remember that logs and exponentials are inverses of each other, and inverses are symmetric over that line y equals x. And what did our exponentials look like? They look something like this. So if I take a look, that green and blue are reflections of each other, so that blue makes sense. Okay? All right, so now what happens though, if we have a little bit more going on? So I'm going to reference number 1 when we do number 2. So number 2 says, let's find the log base 3 of x plus 2 minus 1. What you're going to do is you're just going to identify that parent function first. So the parent function is the base of 3, but simply with just an x. I would convert that. So that conversion is 3 to the y equals x. And then I make my table of values. Here's the good news. We just did this problem. So instead of doing the calculations out, I'm just going to copy those ordered pairs that we came out with. Okay? But either way, when you see transformations, and you'll see that on number 4, you're just going to identify the parent function first, convert, and make your table using the parent function. Once I have those points, we can now use our transformations. So I'll use blue to represent the parent function. Again, we had 1/3, -1, 1, 0, 3, 1, and 9, 2. So now what am I going to do is I'm going to take those points and I'm going to make sure to move them to the left 2 and down 1, right? Based upon my transformations. What affects the x? When it's a plus, it moves to the left 2, and when subtracting 1, moves it down 1. So I'll take this point of 1/3 -1, move it to the left 2, and go down 1. I'll take the point of 1, 0, move it to the left 2, and down 1. I'll take the point of 3, 1, move it to the left 2, and down 1. That brought me actually right to an old point. And I'll take 9, 2, move it to the left 2, and down 1. Now remember that horizontal asymptote was at 0. Sorry, vertical asymptote was at 0, but now I'm moving to the left 2. So now my horizontal asymptote will be at -2. And we can see none of my green dots went beyond that. So now we can connect those green dots with our curve. And there we have it. So what's my vertical asymptote? It is x equals -2. My domain now is from -2 to infinity. Look, I'm not including it, right? I have parentheses. And my range, again, will be all real numbers. Okay? You try 3 and 4. 3 does not have any transformations. So just convert to exponentials, plug in values for y, and get your x's. For number 4, you want to think about just the parent function of y equals log base 2 of x. Convert that, get your points, and then transform. We'll talk about these tomorrow.